Okay, so we're looking at the second year Stats and Mechanics textbook, and we're on chapter 4, which is on moments, and exercise 4E, which is focusing on tilting. We're on the last question, question 7, so it's an exam question worth 6 marks, that's a decent amount of marks. It's also problem solving, so we're going to have to think carefully about how to tackle it. So we have got a uniform beam, weight W, and length 14 meters, and it's in equilibrium. We're sort of shown how it's supported by those cables. Okay, so let's just think about what they're saying. A weight of 100 newtons is hung from A, so hung at the very end, and the beam is about to tilt. The weight is removed, and a different weight V is hung from B, and it does not tilt, so find the maximum value of V. Okay, so now this must be relevant. They wouldn't be telling us this if we didn't need it. So, and they don't tell us, they tell us it's a uniform beam, they don't tell us the weight, but they don't mention, we're just supposed to come up with a value for V. It doesn't say V in terms of W or anything like that. So we're going to need to use this first bit of information to find W. Okay, so let's, but if in doubt, just start drawing it out and see what you've got. Right, so we've got our beam. It's got supported by cables or by wires, cables at C and D. Okay, so potentially there's going to be tension in each of those cables. Come back to that. It's uniform, so its weight is going to be working halfway along the beam. So that beam is 14 meters long, so the weight is going to be 7 meters along, so between C and D. And its weight is W, not its mass. So it's not WG, it is just W, that is the weight. And we hang 180 Newton force from A. And so when we do that, it's about to tilt. So if it's about to tilt when we add that weight, that must be that weight is going to pull end A down and B up. So it would be tilting about C, and there would be no tension in string D or in cable D. Okay, so that information is what's going to allow us to find the weight of the beam. Okay, so I'm just looking at this very first sentence here, not worrying about the next bit at all. Okay, so if it's about to tilt, they don't say it's about to tilt about C, but it must be. Yeah, if I'm adding 100 Newton weight to this end of it, it must be that end's going to go down, which would mean that the end B was going up. Okay, so we're given the lengths we need. So I'm going to take moments about C. So I was told in the question that was 4 meters. I was told it was a uniform rod. So W is 7 meters along the rod, so 3 meters from C. And because it's about to tilt about C, then the tension in the string or the cable at D is going to be 0. So I'm taking moments about C. So that force is going to be pulling down on the left-hand side. That's going to be trying to turn it anti-clockwise. So that's a force of 180 newtons times a distance of 4. And that's the only anti-clockwise moment. That is going to be pulling down on the right-hand side. So that's going to be trying to turn it clockwise. So that's going to be a weight or a force of W times a distance of 3. So 180 times 4, so 720 is 3W. So W is 240 newtons. Okay, so don't forget, so that was a weight, not a mass. So we never had to multiply through by G there. Okay, right. So then let's sketch it all out again. Okay, because then they change things slightly. Right, so now I know. So I've still got the 2 cables at C and at D. So again, potentially they could each have tensions in. The actual weight of the rod is not going to change, so I've still got that 240 Newton force halfway along the rod. But then they say that, so the 180 Newton weight we had at A has been removed, And then we're hanging a new weight from the other end, and it doesn't tilt. Okay, so basically we're adding a new weight of V at that end. Okay, so, and it doesn't tilt, and they want to know what the maximum value of V is. So, if V is too heavy a weight, it will pull B down. So if V is too heavy, it will pull end B down and end A up, which would mean it was tilting about D. Okay. So if it's tilting about D, the tension at C is 0. Okay. So there's this sort of the whole emphasis of this chapter, or sorry, not this whole chapter, this exercise. Okay, so if it's tilting about D, and it doesn't matter if it's tensions from cables or reaction forces on supports, that's the main point of this. So if it's tilting about D, and I know it didn't say that, but we can figure that out from the situation they're describing. Okay, so basically we want to find the value of V that will mean it's about to tilt. Okay, so because that's what they want. So if we find the value of V at which this is about to tilt, that will be the maximum value of V. It's anything greater than that, and it will tilt. So if it's about to tilt, the tension at C is 0. So the sensible thing would be to take moments about D. So if I'm taking moments about D, I don't need to worry about the tension at D. This weight here, I'm going to need my length to do this in a second. So that weight there is going to be turning it, pulling the left-hand side down, so turning it clockwise. Okay, I know, I think we already had to work that out. Yeah, so I know that that's 1 meter. So I thought I changed the colour there, never mind. So I know that's 1 meter from, because that's its uniform rod, so the 240 newtons is still acting 7 meters along the rod. So I know that's 1 meter, and I know that's 6 meters. So they pretty much told me all of that information. So right, so the 240 newton force times the distance of 1 meter is the only anti-clockwise moment, and then the clockwise moment is the force V that we're trying to find, which is the distance of 6 meters away. So that's going to be 240 is 6V. So V is a maximum of 40 newtons. Okay, because if it's any more than that, then it will start to tilt. Any less than that, and we're fine. So let's double check that. Awesome.